Hi guys, today's notes are on chapter 7.2, graphing rational functions. We'll be continuing graphing a little bit more tomorrow, but today we'll just introduce the idea of what is a rational function. So first off, a rational function is a parent function that has 1 over x. So the linear numerator and a linear denominator, but there has to be an x in the denominator, or a variable in the denominator. The tricky part about this chapter is that there's going to be a lot of ways that x can be in the denominator. So you could have just a number on top with x in the denominator, like this, which is vertex form, because this is your up and down shift, this is right and left, and this is your vertical stretch or shrink. Or you could have something that looks like this, where it's an x in the numerator and the denominator, and it still graphs the same way where you have like two pieces, but it's going to look a little different. We could also have it way more complex, where instead of just like a linear on top of a linear, let's see if I have one today. Ooh, we do not. Okay, but tomorrow we'll have like a quadratic on top of a linear function, or a linear on top of a quadratic, and so it gets really complex in the sense that like there's a lot of different types of functions. The first thing we should know is that the parent function is called hyperbola. Okay, so it's when there's like different pieces. Hyperbolas have two asymptotes. And asymptotes are a line that the graph approaches but never touches or crosses. So if you think about like 1 over x, right? If I do 1 over 1, that's 1. 1 over 2 is 1/2. 1 over 3 is a third, a fourth, a fifth, a sixth. But you're never actually going to hit 0 because 1 divided by like a million is still a number, still greater than 0. And same for this side, right? Like it'll get really, really close to 0, but you will still have something technically there. The other thing that you need to know is that there's going to be a vertical. So that horizontal asymptote on a graph, we would draw like this because otherwise it looks like our line actually touches. Okay, so this is at y equals 0. Okay, because it goes through right here at y equals 0. And then this one is vertical. This is where x equals 0. And x cannot equal to 0 because you can't ever divide by a whole number. However, if you divide by a fraction, like 1 over 1/2, that gets really big. So that becomes 2, 1 over 100. Like if I did 1 over 1/2, okay, that on your calculator, if you did that, is 2, because these 1 cancel out and the 2 stays. Well, let's take a look and start graphing then. Let's start with vertex form. Okay, like I mentioned earlier, A is your stretch or shrink, and it's vertical. If there's a negative, then it's a reflection over the x-axis. Okay. Translation left and right is still the opposite signs. And then translations up and down is your k. This one doesn't show up in parentheses, but it's there because on your graphing calculator, you would have to put it in parentheses to show that they're grouped together. And then h and k determine the asymptotes. So let's think about it. If we start at 0, 0, or 0 and 0, and then I shift it to the right, well, the asymptote shifts with it, right? So instead of our asymptote being at 0, if I shift, let's say this is -2 to the right 2, then that's my new asymptote at x equals 2. Let's take a look. So let's figure out what's going on. There is a horizontal translation, 3 right. Okay, so if I take my original asymptotes and I shift it 3 to the right, then my vertical asymptote must be at x equal to +3. Really what you're doing is setting x minus 3 equal to 0, and you're finding what number makes that untrue, right? Like we can't have a +3 be our x value because we can't do 3 minus 3 is 0. Okay, so you're setting the denominator equal to 0 for your vertical asymptote. Horizontal asymptote always starts at 0, and we have not shifted up or down, so it still stays at y equals to 0. And for these, you can write cannot equal to with this slash, or you can write equal to. I'm not going to make a big deal about that. So let's draw that in. Vertical asymptote at 3. 1, 2, 3. If you guys have just regular pencil that doesn't show up well, I like to label and I extend my graph a little bit so the teacher won't tell me like, oh, you didn't have that on there. Horizontal asymptotes at 0. This is y equals 0. And our y-intercept is when you plug in x equals 0, right? So let's plug in x equals 0. So it'll be 0, negative 1/3. And you just graph that as like 0, negative 1/3 right there, somewhere between 0 and 1. Our x-intercept is when y equals 0. So I'm going to go 0 equals 1 over, x minus 3. And this is where geometry comes into play. You can just cross multiply. You guys see that? Anything times 0 is 0. Equals to 1, and that's not possible. So there is no x-intercept. If you did manage to get like x equals 5, then your y-intercept will be or x-intercept will be at 5. But this makes sense because you can't have an x-intercept if our asymptote is there. Okay, so domain and range is going to be everything except this is x values and range is y. It's going to be all real numbers such that x does not equal to, and what's the value it cannot equal to? It's only our asymptote. X cannot equal to 3. Okay. And our range is also all real numbers because it can be anything. Notice here, oops, sorry. Pause this real. Sorry, I had to bang on my desk real quick. But it's range is all real numbers and it can be any y value except our horizontal asymptote, such that y cannot equal to 0. Well, we have these graphs, but it's not really helpful in the sense that we don't know where things are yet. And so what we're going to do right now is we're going to plug in some points. Now, we don't want to actually plug in points close to 0, 0. We want to center it around our vertical asymptote. Okay. Oops. Okay, guys, sorry, I paused to do classes and I can't recall exactly when I left off, so I'm going to just start again. So we're going to have the center, or the new center is right here where it used to be 0, 0 in the origin. And so now what we're going to do is we're going to try to find 2 points to the right and 2 points to the left. We have one already, but if you plug in numbers really far from the asymptote, what you're going to find is you're going to end up with smaller and smaller decimals, or messier and messier decimals. So what we want to do is actually pick the 2 numbers that are closest to the asymptote for my x values. And so that'll be x, and so 2 to the right, so this is x equals 3, right, for my asymptote. So we can't use 3, but we can use 4 and 5. And then on the left side, we don't want to use 3, so we're going to use 2 and 1. And let's see. So when you plug it in, you are going to plug it into here. And you can show work below or do it in your head, whatever works best for you. But essentially what you're doing is 1 over 5 minus 3, which is 1 over 2. And then if I plug in 4, 4 minus 3 is 1, so 1 over 1 is 1. Plug in 2, 2 minus 3 is negative 1. 1 over negative 1 is negative 1, and then negative 2 it would be 1 over negative 2. And so here are my 4 points. 4, 1, 5.5 is just somewhere between 0 and 1. 2 and negative 1 is down here, and 1 and negative 1/2. When you connect the curves or connect the points, you do notice, hopefully, that we are starting to curve in the same general shape as a hyperbola. And you want to make sure you always get closer and closer to the asymptote, which is what this definition says right here. An asymptote is a line that the graph approaches but never touches or crosses. So I need to get closer, and I can only get closer going up, because if I go down, then I'm going to cross over this horizontal asymptote. So I'm going to go up, graph it. Anytime you find yourself getting too close, just stop your line. Like, you don't need to extend it to the edge, right? So, oh, sorry, that's not great. What you don't want to do is like start to curve your line up. So I'm going to make this go down a little bit more. You want it to always get closer and closer. Okay, and so the general shape of a hyperbola should still be there. Let's take a moment. These next two, you can definitely try on your own if you feel like you're ready. I'll walk you through one more, and then I will put up the answers quickly for the last one. Okay. So for this one, let's think about translations. Our translations are -2 left and +1 up. Okay, and so if I'm starting at 0, 0, and I go 2 left, that means my vertical asymptote is going to shift that way. X cannot equal 2, or x equals -2 is the vertical asymptote. I'm going to put cannot equal 2. If you notice, it's what makes your denominator equal to 0. Okay. Put that on there first. So let's see, we're going to go all the way down. I'm going to label this x cannot equal to -2, just for future reference. Horizontal asymptote shifts up 1. Right, so that's y cannot equal to 1. And I'll draw that in right away. My y-intercept, remember, this is when x equals to 0, and x-intercept is when y equals to 0. So you're going to plug in each one and solve for the other variable. Domain and range. Did I talk about this in the previous one? I'm sorry. Domain and range is all real numbers. Oh, did I skip that on the other page? Nope, I did it already. Perfect. Such that x cannot equal to -2. And then range is all real numbers such that y cannot equal to 1. Okay, and once you have your horizontal and vertical asymptotes, you can plug these values in and write the domain and range right away. Let's do y-intercept right now. I'm going to plug in x equals 0. So I have 2 over 0 plus 2 plus 1, which is 2 over 2 plus 1, which is 1 plus 1. We're just simplifying here. So if I plug in 0, I get 2. My x-intercept, draw a line just to show my work. Okay, this one's a little bit more work. You have to set y equal to 0 equals to 2 over x plus 2 plus 1. Okay. Now you can't cross multiply until you have one term on the left and one term on the right. So I'm going to subtract 1 on both sides, and I end up with -1 equals 2 over x plus 2. And we'll make it over 1 so that we can cross multiply. So that gives me 2 equals -x minus 2. Show your work carefully here. I'm going to add 2 on both sides, so I get 4 equals -x. That means -4 equals x. So that means here I have -4 comma 0. When my y is 0, x is 4, -4. Okay, so let's plot our points. -4, 0, 0, 2. This is my vertical stretch of 2. Okay. And let's plot some more points here. Oh, sorry, this should be my asymptote. Let's just continue that. So, dotted, x, y. So if it's at -2, my next bigger number is -1 and 0, and then -3 and -4, right? I have to skip -2. I know this one is already 2, and I know this one is already 0, which is nice in this case. I don't have more work to do. I'm going to plug in -1 here. So -1 plus 2 is 1. 2 over 1 is 2, plus 1 is 3. Then if I plug in -3, -3 plus 2 is -1. 2 over -1 is -1 plus, -3, -1, that's 2. -2 plus 1 is -1. There we go. So now we can plot -1, 3 and -3, -1. So then some students ask, like, okay, so what does that vertical stretch do? And like, how does it change anything? Well, if we go back and take a look, we will notice that away from the origin, we are up 1 over 1. And away from the origin here, we're downward 1, backwards 1. Okay, the second point, that's not so clear. Like, why is it 1/2? But this point matches that right now. Let's see if it is the case here as well. So if it's a vertical stretch of 2, well, it used to be at 1 away, right? Up 1 over 1. And so we've stretched it, which means it's now 2 away. And the other point used to be 1/2, but we stretch it, so it's 1 away. So it's pretty cool that you can actually use stretches to get this other point as well. Okay, I got a little close there, so I'm going to stop. Okay. Next one for you to try, so pause the video and try. Okay, so check your answers real quick. It does look like the patterns so far for the three problems that I've done so far work, where there is a correlation between this first slope from 0, 0 to get your first point, matches your vertical stretch. And this second one seems to be always half of that distance away. Now, as you do your homework, check to see if it's actually true or not, right? Don't believe what I say about patterns, regardless of what you think. So check as you go, show your work, and see if it matches. And if you do enough problems, then perhaps that is the pattern. Let's do our second type of problem now. And this is when we have a variable on top and bottom. And in this case, we're just going to use a formula real quick and know that there are two formulas here. One is for the vertical asymptote. That's a negative, by the way. It's tiny. And one is for the horizontal asymptote. Now, I hate formulas, so tomorrow I'm going to tell you guys about how to do this without a formula and always get the vertical and horizontal asymptotes anyways. But for right now, memorize the formulas or use it on today's homework. So your vertical asymptote, let's use that formula. X equals -d over c, and notice A, B, C, D. You go in order from left to right, top to bottom. So A is 1, B is 2, C is 1, and D is -2. That's -2 over 1, which is 2 over 1. So X cannot equal to 2. Horizontal asymptote is our other formula. So I have Y equals A over C. They're both 1 right now, so that's nice and easy. We can graph that right away. And from this point, everything is exactly the same. Okay, so just so you know, there's nothing new that's coming up. We've graphed our asymptotes. You can plug in 2 points to the right, 2 points to the left. There is no vertical stretch or shrink that's clear anymore, so we do have to show our work. X equals 2. So I'm going to go 3 and 4, and then 1 and 0. Which is perfect because we want a y-intercept of 0, so 0 plus 2 over 0 minus 2. 2 over -2 is -1. 0, -1 right there. And then my x-intercept is, we had x equals 0, so now we want y equal to 0. So 0 equals x plus 2 over x minus 2. I'm going to cross multiply. This crosses out, right, times 0. So you get 0 equals 1x plus 2. So x equals negative 2. So if I were to connect my points, that's how you want to get closer here. So let's see if I plugged in, oh, and I should get that point to be completely accurate. So 0 is negative 1. Let's plug in 1 and see what we got. 1 plus 1 plus 2, 1 minus 2. That's negative 3 over negative 1. It's negative 3. And so you can get more accurate by plotting another point closer. And then on the right side, I have to plug in 3 and 4. So let's plug in 3. 5, I think. Okay, and then this one is 4 plus 2, 4 minus 2, so that's 6 over 2, which is 3. Okay, exactly the same, so I'm going to have you practice the next few problems. I think that's pretty much it. When you have your transformations, you just match your asymptotes. So you guys can finish this part on your own. Nothing new at this point.